All right, welcome to this studying for the final in 2021. We are going to go through chapters 2, 3, 4, 5, no, not 5, 6, and 7. Throughout the questions, I will write the answers or maybe stop to explain, and you can use your play and pause to go through the correct answers. You can see the sum formula here. You can ask Mrs. Edwards if that will be given to you on the test. The next question asks for alternate interior angles. These are the pairs in the corresponding color. Remember that if these lines are parallel, then the alternate exterior angles will always be equal. That means the measure of angle 1 equals the measure of angle 8. And the measure of angle 2 equals the measure of angle 7. All right, in this question here, we can write some measurements in that we can see. D is vertically opposite of 62, so D will also be 62. C, we know, is a straight line here, so that has to add to 180, so we know C is 50 degrees. These symbols here mean that these two lines are parallel, so that's going to tell us a few things. First of all, this angle here will be supplementary, or will add to 180 with 130, or we also can see that it's corresponding to angle 50 degrees, so let's write that in as 50. Then we can know angle A. Angle A is corresponding with 130 degrees, and that makes sense because this is a straight line, and 130 plus 150 is 180. Angle E is vertically opposite 130, so we know that that's true. And now we're looking for angle F. Angle F is alternate interior to this angle. We know that alternate interior angles are equal, so then F must be 62 degrees. So which of these statements is false? Oh, we didn't do B. B is straight across from F, vertically opposite. We say it's 62. This is false. C 50, that's true. E 130, F 62. And alternate interior angles of parallel lines are those two, and of course these should be marked as parallel, and the other two, 5 and 4. Those angles with the same color will be equal if the lines are parallel. All right, moving on to chapter 3. These are important formulas that you will need to know how to use, and you can ask Mrs. Edwards if they will be given to you on the test or if you need to memorize them. Number 3 is another example of using the sine law. Number 4 asks about angle of elevation, and then of course depression. An angle of depression would be, say, a plane in the air flying, and asking, here's the ground. And depression means from a horizontal line looking straight down. Maybe it's looking at that person. This is angle of depression, going down. If you're depressed, you're down. Drawing a bearing, we always start with north, east, south, and west. Then it says south, so we're starting on the south line, and we're going 60 degrees towards the west. That would be our angle. All right, then solving another triangle, number 6. Number 6 is angle, side, side triangle, which implies ambiguity. It's ambiguous. Even though I think the next chapter deals with ambiguous. Okay, we'll have a go at this. I was wrong. It's not ambiguous because it is not an ASS triangle. Once I draw it, I can see that it goes in order from side to angle to side. So it's an SAS, not an ASS triangle. So no, it's not ambiguous, and we can solve it. All right, let's do so. So we know one angle and the two sides beside it. And we need to find this one. So we don't have an angle and an opposite side as a pair. When we have two pairs, like a side and an opposite angle, and an angle and an opposite side, then we can use the sine law. And the sine law is easier than the cosine law, but we have to use the cosine law in this instance. Okay, here's the answer for 6. And number 7 we did in class. There's the right answer. Moving on to chapter 4. This is where we talk about oblique triangles, where one angle is more than 90 degrees. This is when we come into contact with the information in the order of angle, side, side. And that tells us that we are dealing with an ambiguous triangle. It's ambiguous because there could be 0 triangles with that information, there could be 1 triangle, or there could be 2 triangles with the given information. It's hard to know. Okay, the question is, in this triangle that's sloppily made on the top of the page, what is the shortest that side A can be? We know the shortest way to go anywhere is directly making a 90 degrees. So what we want to find is the height of that. That's the shortest possible that this side A can be. Now in a 90-degree triangle, we can use SOHCAHTOA, right? We have 40 degrees, and straight across, or we say opposite, is the one we want. And we also have the hypotenuse. So opposite and hypotenuse, that means we use sine of 40 equals the opposite, h over the hypotenuse. And then if we cross multiply, h should be equal to 7.7 centimeters is the shortest that A can be. All right, so next answers are. So we're again given this order of information. Whoever made this question put it in the order that doesn't spell a bad word. The bad word, though, anything in that order, angle, side, side, or you can reverse it and say side, side, angle, is ambiguous. You have to decide how many triangles can be made. So we need to draw it. Now, when you're drawing these, it's always best to do them exactly the same way every time. So I always put my angle on the left. So I draw this, and the 35 would go here. That's B. Okay, that's that information. Now, side B here is going to be straight across. We're not sure where this is going to touch. Okay, that's what's ambiguous. It's either going to touch once, it's going to touch twice, or it's not going to reach at all. It could just dangle there. The other side that we know, A, we're always going to put it here. Okay, that makes this vertex A, and then this must be C, some other number that we're not given. Okay, so now what we have to do, same as we did on the top, we need to find this shortest possible to make one triangle. We call that the height H. Okay, so again, because it's a right triangle, we can use sine of the angle we know is going to equal the opposite, which is H over the hypotenuse. And in this case, H works out to be 8.9 meters. All right, now that we know that's 8.9, we can see that this 12 should be drawn a little bit longer than it is. We know that 12 will touch here, and then also if I were to swing that 12, I didn't draw it all as one piece. Let me try to draw this nicely. And I deleted too much. That's okay. We'll draw the 12 here. That's one triangle it could make. And then if I am able to, I want to try to swing that over. I can't. It won't let me flip it. Okay, I'll just draw it again. Another 12 would work here. We know that because 12 is shorter than 15, so it's going to touch there. So here we can make two triangles. What about this? If we draw it again, 35 here, this is our 15.5. Here's our arm, not sure how long, but we know that this shortest possible here is 8.9. So this guy is not long enough to touch. No triangles. 2 triangles, no triangles. And let's see this last one. Same setup. We always put this bottom angle on the right that we know. Here we have a side length of 17.6. That's pretty long. It's definitely longer than 8.9. It's longer than 15.5 too. So this triangle, 17.6, is going to be way out there. This one we can't swing. If I swung 17.6, it wouldn't be able to touch somewhere over here. We couldn't do it. Just one triangle. Okay, Leaning Tower of Pisa. And you would use the cosine law then to find number 7. Chapter 6. Now we did this one in class. You can stick a -1 in for x and a +1 in for y and see if they both work. And here's number 2. Notice that I used red just to show which line was which, but it all should be shaded green because of the real numbers. Okay, giving example of natural. Natural include anything from 1 up, 2, 3, ... Whole numbers include all that, except they also add 0. Integers include all that, except they also add all the negatives. So it goes all the way from negative infinity, -1, 0, +1, and all the way. Real include everything between those, like all the decimals between there. So, it's hard to write that all out, but even -1.2, -1.1, -1.0, all the way up to positive infinity. So all decimals, all fractions, etc. All right, everything we know about this graph, you're good at this. And lastly, chapter 7. There's the work for those 2 questions. Remember, when you're factoring, you want what multiplies to, in this case, the C, the last number, and what adds to here. Here and here. You can also do that the long way using decomposition. Okay, we want to find the coordinates of the vertex. Remember, vertex form, you're given this on your test, is ax minus h squared plus k, where h comma k is the vertex. So the vertex here is 3 comma 8, +3. The equation of axis of symmetry, well, it's going to go right through the x, right? The axis of symmetry always goes right through the vertex. And so, the axis of symmetry is going to be x equals 3. And a sketch of this graph. Okay, well, let's see. Here's x equaling 3. It is concave. Remember how to find this? Here, this is negative, so it's concave down. So, and our coordinates of our vertex is 3 comma 8. There's the 8 on the y. And so a really sketch of it would be like this. Right. Determine the equation in factored form. So factored form, remember, here's vertex form. Factored form is, and the last 2 questions using the quadratic formula, which you'll be given on your test. And the first has a solution set of 3 and 8. You can plug them back into the equation for x to check. And question number 5, you need to put it into standard form before you find the a, b, and c. So the solution set here would be x is equal to -2/3 or 4. All right, good luck. If you have any questions, send me an email and a photo of your work.